Okay, let's get started. So we got 18, I think, out of 71. Definitely the majority. So are there any questions? Ready for spring break, I hope. So I actually have to leave class 5 minutes, maybe a little bit more early, because I'm giving a guest lecture in a different class. So I gotta go all the way to Brickyard in 15 minutes after the end of class. So I have to leave a little bit early. Yeah, but are there any questions? Oh, so I posted assignment 5. That should be quite a bit easier than assignment 4 was. So I admit assignment 4 was quite a bit challenging, but it should have made you think about how to approach it more than just coding a lot. And assignment 5 should be like that too. Try to minimize the program as much as possible. Okay, so if there are no questions, we'll get back to this stuff. So we talked about these things called objects. So what are objects really?
Places to store data.
Yeah, it's just places to store data, but what also do we define about objects? What else do we say about objects other than just storing data?
You can manipulate that data as a whole.
Yeah, manipulate data via what? Functions, or more generally, operations. So we have some data, we store it all in one convenient place, and we say, we're going to define this operation on this data, this operation, etc. So that's what we've been talking about mainly. So we've been working with this example of a circle, and the only piece of data that we need to know about a circle to fully understand a circle is the radius. Because could we get the area only from the radius? Yeah, because it's just pi r squared. We can get the circumference, everything that we need to know about a circle, just from the radius. So we store this as the piece of data inside the object. Why does it say class here, not object? We are defining a, so what is a class really?
It's like creating a definition for.
Yeah, so we're creating the blueprint for a circle. So a class is just a blueprint for an object to be created. So the analogy I came up with before was, a class is a blueprint for a house, and the object is the actual house that comes from the blueprint. So a class is just a blueprint to create an object. So a circle, you can create a circle by declaring it down here and then doing the operations on it, passing values, etc. Okay, so that's the example we've been doing. We talked about hiding data. Then I think we came down to here, somewhere around here. So their example is using a square, but it's essentially the same thing as what we've been doing with the circle. So we can access the members using the dot operator. Can I access private members using the dot operator? No, because with private either functions or data, I can't access them directly, which is the dot operator in this case. So, but I can access anything public. So looking at this, what can we infer about the set side function? Is it private or public? Yeah, public. What about get side? Is it private or public? Public, yeah, because we're accessing it via the dot operator. So we're looking at the object SQ1 and saying dot operation in this case. So it's public, it can't be private. So you may be noticing we're doing these set the variable name to something and then a get version of the same thing. So for a square, for example, we have a set side function because the variable name is side. We have a set the variable name side and a get variable name side. In the example that we've been doing with circle, we have very analogous things. We have a set radius function and a get radius function because the variable that we're considering is radius. So what we're saying is we do want to have access to this underlying variable, but you have to go through these functions. You have to go through set radius if you want to set it to something, and you have to go through get radius in order to get the value out. So you may be wondering, okay, well, so let me ask you this. Why don't we just set radius to be public and avoid this get set nonsense? Why can't I just set this public if I have both of these declared public? I can set and get the value, which are all the things I can do to a variable. So why don't I just declare this public and remove all these? What? It's too easy to change, but I could equally well say set radius to whatever I want. It's not as clean, but I can still do the exact same thing. So why would I prefer this way? So instead of thinking about circles, think about a bank account. So what if we said, okay, well, you can deposit and withdraw from this account, so why don't we just set the bank account's balance to be public instead of having this deposit withdraw nonsense? I mean, I can change it arbitrarily in the deposit withdraw function too. The withdraw and the deposit function. So why would I do it this way? Think about the bank account. What does the bank have to do? So let's just say that you're depositing a check right now. Does it immediately go into your account? No, what happens? They have to verify it. So in the, say, set radius function or deposit or withdraw or whatever, I can put additional code inside this function like a authorization type thing or something else. So could I do that if I just made the variable public and got rid of the two functions? No. So that's the advantage of doing it this way, because even though if I just left it like this, which is the convention, I get exactly the same thing as if I just made the variable public. The advantage here is I can put additional code inside the set and get functions. So like if I wanted to have a function inside of circle if we validate the radius. So like if this is validated, then we can set the radius to be equal to a validated value. So now we can do additional checks here that we couldn't do if we just made the variable public. So that's why we have set and get functions. Any questions about that? Yeah.
Is validate like an included library function?
No. So we would have to write this function ourselves. So an example would be, well, do you think it would make sense for the user to see this validate function? No, probably not. So should it be private or public? Private. So maybe we could have this validate function. It has to return a bool because I'm doing a bool check right here. I'll get to you in a second. What could be a validation thing for circles?
Well, it has to be greater than or equal to 0.
Okay, so maybe we can just say it's valid if r is at least 0. Cool. And so now we'll think about what happens. What if we set in a bad value like -1 into set radius? What happens to the normal the radius on the inside? Nothing, because in this case the if check failed and there's nothing else after it. So with this function, setRadius, I can do checks to see if the thing that's going to be set is a valid value. So that's why we have set and get functions. Any questions on that? I think you had a question.
Oh no, I just had a general question about this.
Yeah.
More people ended up coming to
Yeah.
that sort of thing.
Yeah.
Should we keep it going?
Yes.
Okay.
Yep. Any questions about this though? Okay, so let's talk about a little bit about those So these functions, I usually call them getter or setter functions because it's get this or set this, so it makes sense. There are other terms like accessor and mutator. They mean the same thing, but I'll probably say just getter setter. Yeah, so the function get whatever or set whatever, it doesn't have to be get this or set this. I could change that to be deposit or withdraw or whatever. So it doesn't have to be get this or set this. Okay? Let's see. So yeah, so I can rename it anything I want, but the convention is get whatever, set whatever. Yeah. Okay, so let's talk about the way that this is formed, the class that we've made so far. So these functions right here, these are what are called inline functions, okay? So inline with respect to the class, I mean. So yeah, so a lot of the time you put functions directly inside the class scope. So you make a class right here, you open it with the curly braces, and then you put the functions right inside. Those are inline functions. There are different types of functions, which we're going to get to in a second. Usually you want to put small functions like this inside the class, because if you have a long function inside the class, it may be hard to read whatever else is in the class. But if you have a small function like getting a value, then that's usually a good idea to put inside the class. Yeah, so this is just an example, pretty much exactly the same as what we've seen. However, sometimes if you have long functions or you're OCD about your class, what you do sometimes is you put the function declaration after the class. So if we have this is not a long function, so don't do it with small functions like this, but if you have a long function, this is a good idea. So how many of you have seen std : something? Yeah, so that's what is called the scope resolution operator. It's actually something called a namespace resolution operator, but it does the same thing. What it does is says, okay, the thing on the left of the double colon right here, that's where this function, you should look up where this function is. So this function getSide, this should be declared inside the square class. If we wanted to do something like this for our circle class, well, let's just say we wanted to move the set radius outside. So I'm going to cut it out, paste it out, tab it back, and then instead of square, what we would do is circle. So circle : the function that we want. And then inside the class, well, it says the set radius function is declared inside the circle class, but do you see it declared inside the circle class? No. So does it really make sense for me to have two copies of this function, one inside the class and one outside the class like this? No. So let's just say I'm adamant about putting it outside the class, but I need to have something inside the class. What do you think should go there? A prototype. So what you would do here instead is put a prototype in by removing the function body and putting a semicolon there. So we've seen prototypes before, which solved a problem that we had earlier. Now we're seeing them here in that we're declaring the function inside the circle class, and we have the actual definition of the function outside of the class. So it's very similar to what we had before. There's a very good reason why we're doing this, which will go back to when we make new files. So instead of having all the code in one gigantic file, we're going to split them into multiple files. And we'll talk about that in a bit. But any questions on using the scope resolution operator? So when do you use it? For relevant to this, where do you use the double colon?
Function is outside the object declaration.
Yeah, it's when the function that you want is outside the class. That's it. But here, should the set radius function live by itself unrelated to circles? Probably not. So, but a set radius function makes sense with respect to a circle. So that's why we put the circle colon colon here. Now, there's actually something that's actually missing right here. So if we try to compile this, I'm pretty sure it won't even compile. But just to show you that there is something missing. Yeah. Extra qualification. Okay, I wasn't expecting that. Oh, okay. I can't have the circle colon colon inside the class because, I mean, it's in the class. It knows it's part of the circle class. So I don't need to put that there. Okay, well, yeah. So, yeah, there's something that's relevant to this, which is this radius right here. What if we had a double radius right here? Radius equals 1.0. What if we had a radius right here? It could, in principle, say this radius right here really refers to this one, and not the one inside the class up here. So there's an extra qualification you could do on this variable right here to make it say, yeah, I refer to exactly the one inside the class, not any other possible one. But we're not there yet. But any questions on just using the scope resolution stuff? Okay, so let's see. What else we got? I think I've talked about most of this. Variables are usually private. Functions are usually public. Sometimes it makes sense to only be able to read a value and never set it. Or, like for example, what if we had a version number on our class? Like on our circle class. We had a 1.0 version, 1.1 version, whatever. Would it make sense for someone else to set that value to something? No. So that in that case, we wouldn't even make a mutator function. So, but we would make an accessor function. So maybe we want to check if the version of our circle is 1.0, then we can perform this operation. If it's 1.1, we can do this other operation. So sometimes it makes sense to have only accessors available and not mutators, or to have both, but one of them be private and the other one public. It really depends on the situation that you're dealing with. But usually they're public. Use the get when you want to mutate something, get when you want to access something, set when you want to mutate it, just as you might expect. Yeah. If possible, use member variables to calculate a value to be returned as opposed to storing the calculated value. So let's see. Use member variables to calculate a value to be returned as opposed to storing the calculated value. So think about it from a circle's perspective. Is there any real reason why I should store the area here? No. Let's just say I did. So let's just say I had an area thing like this, and then in public, we would have a function double get area, and then we returned our area. Fine. And maybe we have a set area, whatever. Okay, why might this be a pain to deal with? Well, here's the thing. With more than one circle, they have their own radius and area. It's not shared between them. So that's not actually an issue. What if I update the radius? What else do I have to update now? The area. because I'm storing the area inside the circle. So if I update the radius, now I have to also update the area. So what this paragraph at the bottom was saying is, calculate the value that you want and return it. Don't store it if you don't actually need it. Do I need the radius here? Could I equally say, I'm only going to go with area and nothing else? I could. But let's just say I said, we're going to have the radius. Do I need anything else? No. So it's actually a good idea to not have an area variable, but I still want to get area function. I want to know the area of a circle. So what do I do instead? I calculate it and return it. I don't save it inside the object. So in this case, it would be, I'm just going to be sloppy and say 3.14 times r times r. Actually, it should be radius, because I want to refer to the variable here. So here, I'm not saving the value of this calculation inside the object because I don't actually need it. Because if I know the radius, I know the area anyway. So just be careful in that if you store more than you actually need, then you may have to update things more than you actually want to. Yeah.
What would end up happening if you used R instead of radius in this case?
Good question. So what if I did R like this? Anyone have an idea? So if I try to compile, what do you think will happen? There's an error. So it's looking for an R variable, and it can't find it. But wait, there's an R variable here, here, and yeah. So there's a variable R declared, but what's their scope? Just those functions. So this R right here only belongs to the validate function. Cannot be accessed anywhere else. Same with set radius. So the one I actually want is the variable that's stored within the class. So I do need radius in this case. Other questions? Okay. So let's see. Yeah. So some trade-offs. When a regular function is called, control passes to the called function. So just as we expect. Yeah, you don't need to know this point right here about the compiler storing the return address, but that's basically how if you actually run this where it actually passes control, how does it know to go back to the original caller of the function? The way it does it is it stores something called a return address, which is basically the exact point that you were before. It stores that, does the work over here, and then removes all of the work it did before, looks at the return address, and jumps back to that return address. But you don't need to know that. It's just for your knowledge, but you don't have to know that. Code for an inline function. What's an inline function? Yeah, a function that's inside the class. So code for an inline function is copied into the program in place of the call when the program is compiled. In the place of the call, yeah. Okay, so this is basically what we have seen before. Yeah, so the interesting thing about functions is that they can be what is called inlined. So think about this. So let's just look at our function right now. Let's just look at the get area function, and it says return 3.14 times radius. So let's just make this really simple and just work with one circle with one set radius. And then I call get area. So what it could do is say, okay, here's the function right here. I'm going to jump from here, jump all the way to get area, do the actual calculation there, figure out what the value is, come back to the cout statement, and then we're done. And then we'll print the value. What actually happens sometimes is if the function is small enough, and there's a whole body of literature of what small enough actually means, what will happen is this value will actually be copied down into here. So it won't actually jump to the function, do the calculation, and then jump back. It will just inline the entire body of the function right where the call of the function was. So we called get area here, but it'll actually move the entire function's body of the function down into here. So, but notice I can't actually set the, yeah, go ahead.
So this is all post-compilation. So this is
This,
the machine code?
yeah, so when it's doing the compilation, it may sometimes do inlining of functions. But I can't actually access the variable radius like this, so I have to call get radius like this. So, so you don't have to write code like this, but the compiler is really helpful sometimes in that it will actually do this copy of the function, inline it for you, so that your program can actually run faster. And there's a whole slew of ways of enforcing that a function be inlined, or saying, yeah, you could probably inline this, or don't inline this. There's a lot that you can do here. But it's really nice that you can actually avoid making the function call and coming back sometimes. Yeah. It can make for a larger program because you still have this get area function back in the circle class, but you basically have a copy of it down here. So you basically have two copies of the program or of the function. But so the program size can be larger, but it can be a little bit of a trade-off in that you can actually have your program run a lot faster that way. Okay, any questions what an inline function actually is? Okay, so you notice back at the circle object right here, notice when we made our circle object, let's just look at C right here, notice that we had to immediately call set radius. Does this code look nice? Declaring a circle, then set the values inside of it? That probably isn't a good idea. Well, I mean, you could do it, but it just doesn't look nice. Well, what if we put, for whatever reason, maybe a color of a circle? Then we would need to have a set color function and then pass that. What if we had more variables here? Then we need to start setting more stuff to it. And then we would have like a c.setColor blue or c.set something else. We would have more set methods like this, and this just becomes really ugly really fast. So you may be wondering, well, is there a way that we could do all of this set business right in the line where we declared our circle right here? Set its radius and its color and any other properties it has right in the same line. So that's what a constructor does. So a constructor is basically initialization of the object. So when we make our circle, we put in the constructor anything that we would want to set up the object. So do we want to set the radius to be something? Do we want to set the color to be something? So that's mainly what a constructor does. It's automatically called when you make an object, which is cool. So, so do we have an example? Yeah. So just a few things about constructors. It should be public, although there are cases where you don't want that, but usually you want it public. It has to have the exact same name as the class. So in our case, we need to have a constructor of name circle. So it has to match the name of the class. But here's a really interesting thing. Constructors have no return type. So this is the only function, quote unquote, that doesn't have a return type. Great midterm question. Do constructors have a return type? No. So they are the only thing that behaves like a function that doesn't return anything. So how would you actually make a constructor? It's really, 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 really simple. So look at the square example. So here's the class square that we had before. Then we have, this is the constructor, these two lines right here. So notice it's in the public section, so it's public. Then the constructor has to have the same name, and we see it does, so that's cool. We put parentheses just like a function, so it behaves like a function. And then we pass in a parameter. In this case, we're passing in the side length that we want to set it initially to. And then on the inside of the constructor, we set up the variables as we may want to do. So if we want to set the squared side length to be 42, then the internal variable side will be set to 42. So, and then we can do any other initialization code that we can do here. So let's do it for our circle class. So we want to avoid having to call set radius and set color like this. So what we would want is to say the first argument of our constructor is the radius length that we want it to be. Let's just say 42. And then we can pass in the color as the second argument as a string. So let's just say blue as an example. So here, so where should the constructor be? Should it be in this part, the first part, or in the second part? Second part, because it's public. So what's the name of the constructor?
Circle.
It has to be circle. Why? It has to be the same as the class name. Yes. So it has to be circle. So what should the type of the first argument be? It should be a double. What should the second types be? String. In general, if you have variables like this that you're going to set, pass in the same type. So here, our internal variable radius is a type double, and color is a string, so pass in a double and a string. So I'm going to actually have these be different names than the internal variables for a reason which we'll see eventually. So I'm going to have a double radius called R, and a string color which is called C. So if I want to set the internal variable radius to be the one that was passed in, then I would do radius equals R. And then if I want to set the color to be the one that was passed in, I do something very similar. I say color equals C. And that's it. So if I look at this down here, I can create a circle all in one line, which is really nice. So let's compile, and then we can, I can run it, but there's no need to in this case. What if we wanted to have it be that the default color is black? So I don't have to, if I don't specify a color, it's defaulted to black. What would I do? Yeah, I would have a default argument here. So let's just say black in this case. And then for this reason, I can create a second circle which has a radius of 500, but no specified color. So then it would have a default color. And it compiles and runs. So this is actually pretty cool. I can have a gazillion, scientific term, number of variables in our class, but I only need to specify a few and then have all of the other ones be defaulted to something, which is really nice. What if we wanted to just create a circle and then not specify a radius or a color? I could set a default for both, and that actually would work in this case. But there's something that is different here that is called a default constructor. So what a default constructor is a constructor with no arguments. That's it. So a constructor with 0 arguments like this is a default constructor. So if I don't pass any parameters in, then it'll just call this, and then you don't have to set the values if you don't want. You could just say radius equals 1.0 color equals black. You could do that if you wanted to. But there's actually a better way to do this, which we haven't seen before. But you can have a default constructor like this, that default constructs the object, initializes everything to defaults. But I agree that you could do a default argument on this one, and it'll work just fine also. Yeah.
Does it still work with our validation function?
No, a great question. So does the constructor do the validation? No, it doesn't do any validation, because all it does is it sets the internal variable radius and color. So what would we do? What should we do here?
Call
The validate function. Good. So if validate R, then we can set the radius and then color. And then maybe if it's not validated, then we may have to decide what does that actually mean? What should we do here? But if it is valid, then we can set the values accordingly. So the great thing about constructors is not just setting the value, but you can do additional stuff like validation. Okay, any questions otherwise? Okay, so I think we talked about overloading before, but you can overload constructors too. So what is overloading in the general sense? When we talked about it with functions, what is overloading? Yeah, right, two functions with the same name, identical name, but what differs?
the type that you're passing.
Yeah, the parameters. So there's something different about the parameters, yes. So it's exactly the same scenario with constructors. So if you, basically with the circle, if we had the default one and the one that we made, that's overloaded constructors. It's exactly the same idea. Constructors can have any number of parameters, just like functions, no difference there. A default constructor is one that either 0 parameters or everything's a default. Because if you have everything default, then if you pass nothing, it's essentially doing the default arguments anyway. So either 0 parameters or everything being default, that's a default constructor. Yeah. So if you make a constructor, you should have a default one, just to be helpful to anyone using the class. So this is just an example of a default constructor. We kind of already saw this. So 0 parameters, and then we set the variable to be some default value. Nothing really interesting there. If you want to invoke a particular constructor, then you need to put parentheses with the argument. So in this case, this constructor that it's invoking is any constructor that has an int parameter. So if there's a constructor with a single parameter that takes an int, then square2 is going to call that one. Is square2 going to call the default constructor? No. So what is a default constructor? It has 0 arguments. What if I just remove the 8 and I just said that? Then it would call the default constructor. But another way that you can call the default constructor is put no parentheses on. So like with square1 right here, that automatically calls the default, which is kind of cool. So, so you don't have to do any setting of any variables. You can just handle everything right in the constructor. Okay, any questions on constructors? One more slide, I promise. All right, so if we talk about constructors, we got to talk about something called a destructor. And this is probably the first feature that we've seen of C++, where C++ beats all other languages, pretty much. So I don't even know of any other language where you can specify your own destructor. So what is the purpose of a destructor? So the constructor that we've been talking about is when the object comes into existence. We've set the variables, we allocate all the memory that's needed for the object, everything about the object is created when you call the constructor. When the object is about to be destroyed, it calls the destructor. Okay? So a destructor is when the object is about to be destroyed. So when might you think, is an object going to be destroyed? So think about the main function right here. Look at this last curly brace right here. Are these three circle objects going to be needed after that last curly brace? No. Why? Well, the program's done, but more generally, why would we not need them? Because they have left scope. What is the scope of C, C2, and C3? Main function, or really in the function that they're made. So when the function exits, do I need those variables anymore? No. So in fact, when these functions go out of scope, when these variables go away, then their destructor is called. So how do you actually make a destructor? So what you do is you put a tilde with the name of the class, square or circle. So to actually show you that this really does happen, I'm going to make our destructor right here. So I'm going to print destroying inside of the destructor. So if the destructor is called, then we will print this. So let's just see. So let's compile, hit run, and it really is calling the destructor on all three objects. So when the object goes out of scope for whatever reason, then the destructor is called. Yeah?
Could you use that destructor to assign it somewhere, like to retain the information?
Good idea. So could we, so the question was, could we say, okay, in the destructor, can we like save the data somewhere? And the answer is yes, in some sense, but that's typically not how you do it. There's something called dynamic memory allocation that allows us to preserve an object after the scope of the function ends, but we haven't talked about that yet. Everything that we've made is what is called stack allocated. So there's no funny business happening here. So at this point, the destructor is completely useless because when a destructor of an object is called, the corresponding destructors of all the variables are also called. So like the double will be destroyed and the string will be destroyed right at the end of the destructor. But it's just when we do something special called dynamic memory allocation, we have to do something extra. So in fact here, I don't have to set the destructor here because it's automatically called. But if I wanted to do something special, then I need to actually declare it myself and then do something with it. Any other questions? Yeah?
Does it matter where inside the function you put in your destructor?
No. So it doesn't, for classes, it doesn't matter where you put the function.
Oh.
Yeah. Which is kind of weird, but that's how it works. Any questions before I let you go? Everyone ready to go spring break? So go have fun. I'll see you in 9 days or 10 days, I'm not sure.